Okay, in this lecture, we learn about different indexes of range. In terms of features of the range, it's very quick to calculate. We simply take the highest score and subtract the lowest score. And so range is therefore a single number. Oftentimes, the mistake is to express the range in terms of an interval, lowest number to highest number. The range is actually expressed in terms of a single digit. So if I have the lowest number being 1 and the highest number being 20, the range is 19, indicating that I have 19 units in between my lowest range and my highest range. In terms of the advantages, it's a useful metric to kind of get a quick and dirty look at what the range of our variables are. It's a nice way to get a kind of snapshot of the variability. If we go back to the previous lecture, we can find out what the tail end, the lower tail is and the higher tail is from the range. But the range is dependent on only two scores, and so it's kind of a crude index of variability in a distribution. The interquartile range is something that is very, very useful, and this is discussed in detail in section 4.2 of your text, and there's some illustrations that are available to you in Revel to help you kind of work with data sets to arrive at the interquartile ranges. We want to use formulas to calculate the interquartile range, and the quartile range is sensitive to concentrations of scores around the center of this distribution, which is why it's so useful. A larger interquartile range is going to indicate a larger spread of data. So in order to find the interquartile range, we find quartile 1 and quartile 3 and then subtract the values. And this is going to give you the spread of scores that are in the 50% of all of the values. You need to look at section 4.2 in the text to help you visualize and to work with these numbers. In terms of how we interpret the interquartile range, the first quartile is going to equal the 25% of cases that are at or below that score. So if you want to know where the first quartile is, that's going to tell you what score is associated with 25% of that distribution. So it might not be the bottom quarter of the values along the x-axis. We're talking about where 25% of the observations lie. The second quartile is going to give you the 50% of cases are at or below that score, and likewise then the third quartile is going to indicate 75% of cases that are at or below a given score. And so the interquartile range is very useful in most applications when you want to know kind of in general where 50% of your cases, where 25% of your cases, etc.